Other services section. Okay. Other services section. Just a second. Okay, in this section, we are going to have look at some of the services that you may need to know, but you must actually not need to know for the solution angle professional exam. So some of those services comes up of the AWS resources comes up are the CICD resources, Cloud Search, Alexa for Business. Then we have the Alexa. Then we have Connect, Lex and Connect. AWS recognition, it's just face recognition, facial recognition, object recognition. These are the services. Kinesis video stream and AWS workspaces and Amazon workspaces, Amazon App Stream 2.0, Amazon Mechanical Turk. Then we have device farm. Then we have Massey. Then we have transcript. Then we have workdocs. So it's going to be completed quite soon, and it's going to be a very short section. So let's again begin here with the first of all that the service we have is the CI/CD related services. So continuous segregation, continuous deployment, continuous delivery. Then we will be going with the all of the services that is available with the AWS for maintaining CI/CD pipelines. Okay. So now let's talk about the CI/CD, and the CI/CD is a bigger focus in the certified developer exam, and I have passed that. Don't worry about that. So I would let you go through all of the things. Don't worry about it. So, but you still need to know how it works for the solution architect professional exam, and so let's go back to the basics of continuous integration, because developers push the code very often to a code repository, and that could be GitHub, CodeCommit, or Bitbucket. So the developers push the code, and what you need to do is make sure the code that they push is valid and it can be built. So you would have a build or test server that will check the code as soon as it is pushed, and services that help with this is like the CodeBuild on AWS, for example, or Jenkins continuous integration or other ones. And so the idea is that the build server will retrieve the code from the code repository, build it and test it to see if it validates what it needs to be done. Okay, then the developers will get feedback about the test and checks that have passed, failed, or and so on. In case there's a failure, the good thing is that we are getting bugs early and we can fix them as soon as possible. So continuous integration now is into every modern company's workflow, and the idea is that you are going to deliver your software faster because the code is tested continuously. And finally, thanks to this, like, we are going to deploy more often, and the developers are happier because they don't need to run the test on their own machine. They can wait for the build server to run the test for them, and sometimes test suites can take long time to run. Okay, based on the depending upon the actually the test that you are running. And then we have the continuous delivery, then the continuous deployment. So continuous delivery here. So continuous delivery is to ensure that the software can be released reliably whenever needed. So the idea is that we are going to deploy often, and it needs to be a quick deployment. So we want to shift away from the mindset of one release every 3 months that can be catastrophic, or to let's do 5 releases a day, and then every release is very safe. That usually means that we have to automate the way we deploy our applications onto our infrastructure and some services. And so let me show you these all of the diagram. Some services that can help with this is going to be the AWS Code Deploy and our Jenkins. If you have actually made some of the pipeline of the Jenkins, it's good to actually have the experience of that, and it's a good service also. Even the Code Deploy, Jenkins is pretty much the same, but the Jenkins is all the third party thing, and it kind of every company uses that Jenkins. So Jenkins, a continuous delivery, or a Spinnaker, or some others. So let's look at this, what looks like. Okay, the developer puts the code often, and we have the continuous integration part that gets the code, build it, test it, and then once the build has passed, there will be a deployment server that will be deploying the application every single time the build passes. And so our application is going to be in version 1, and the deployment after it happens will go to the version 2. And as we go and push more code, we are going to get more and more deployments. So this is how the continuous delivery works. So there's a technology stack for CI/CD in AWS, and as some of the actually the alignment has broken, but it's not that much because we just over. So like there is a phase of the code: build, test, deploy, and then provision the infrastructure to deploy on. So code commit is a code commit is a code repository, and this is the AWS version. Okay, the similar service offered online is GitHub, or you can use a third-party code repository, but this is not AWS native. Then once the code is in code commit, you are going to have to build it and test it, and for this you use AWS CodeBuild, and this is a great service for doing both of these things. And the beautiful thing is that there's no time limit. Okay, no time limit to however long your builds can run. So it is better than using like say Lambda function to test your code. So code build is the way to go when you want to build and test your code on AWS. But a similar alternative that's going to be a bit more open source and cross cloud provider is going to be something like Jenkins continuous integration or third-party continuous integration server. Then for deploying and provisioning, we have multiple options. Beanstalk works really well because we can provision the infrastructure with Beanstalk and also use Beanstalk to deploy our application gradually to our EC2 instances, or we could use EC2 fleet that we manage ourselves. So maybe we have created it using CloudFormation, or then we could use something like code deploy to deploy our code to this EC2 instance fleet. And how do we manage the orchestration of all these steps in our CI/CD? Well, for this, we are going to use AWS CodePipeline, which is allowing us to define a pipeline to orchestrate all the steps. Okay, let's go through. Let's go through a real example of how CI/CD architecture looks like in a company. So this is product environment, just a bit of a view, and and this is something you are expected to know, and this is going to be the extent of what you are going to be tested on at the exam from and solution architect professional perspective. So the code is going to be in code commit, and you are going to have different branches for your code, the dev branch and the production branch. A branch is basically a version of the code, and that's going to be independent from another branch. And it could be even the feature, the branch could be even the feature. Okay, and so while you do development, you are going to be modifying the development branch, and then when you will be done, you are going to merge the changes from the development branch into the production branch. So what happens with the development branch now is that there we are going to define development code pipeline, and what it will do is build that code using code build, maybe test it as well, and the code build is going to source the code from the developer branch of the code commit, and then once it is built and tested, we are going to deploy often. So we'll hook it up to code deploy through code pipeline, and then code deploy may deploy us, for example, to a Beanstalk environment in dev, or it could be an auto scaling group, or something different. So it's really up to you to see how you want to do it. Then the dev branch will get merged into the production branch once we are ready to be in a good state for our application. So the way we do it is that we look at the Elastic Beanstalk environment. So we look at the Elastic Beanstalk dev environment and say, yes, the Elastic Beanstalk dev environment does look good, and I am happy with the state of my application. I want to release it to all of my users globally, and therefore I am going to take the code from the dev branch, do a pull request, and merge it into the production branch. So we are going to create a production code pipeline, and we are going to do a code build to build that production branch, and a code deploy to deploy that changes into say a production environment for Elastic Beanstalk. But again, you have different options. It could be CloudFormation, all these kind of things. Okay, and this is the idea of CI/CD architecture: continuous integration, continuous delivery, and then continuous deployment architecture. So what you need to get out of this is that you need to create one code pipeline per branch in your code commit repository, and there is no way of doing one code pipeline for both. And then each pipeline itself will have its own instance of code build, code deploy, and its own Elastic Beanstalk environment to properly separate your dev and production environment. Another important architecture is around using Lambda with code commits. So when you push the code into code commits, every commit can trigger a Lambda function, and this function can do a lot of things. But for example here, it can scan for leaked AWS credentials on every code post, every code push. So usually AWS have their own native resources that scans the code through the all of the entire repository throughout the world, throughout the globally. Whenever actually even some of the secret being leaked, you will get notification around the next 5 minutes maximum through the even the some of the services from the GitHub you are putting on the GitHub. So that will be, even if you are making it globally, I think if you are putting on the GitHub, it will be notified within the 5 minutes. So it can scan for leaked AWS credentials on every code per se, and disable them automatically to remediate the issues. So how does that work? So well, developer pushes the code into code commits. Code commit invokes. So here this bottom one is AWS SNS for the notification. So code commit invokes a Lambda function, and the Lambda function has some special code to scan for credentials. If they are found, if they are found, then the Lambda function can do an API call to disable access keys in IAM, and also lock the code commit repository, and also send a notification to an SNS topic that would be directly linked to notify an administrator by email, for example. So this is what the Lambda integration with the code commit could do. Other good things to know about CI/CD is that you can use a manual approval stage in code pipeline. You can run unit tests using CodeCommit, CodeBuild, and CodePipeline. So you create a code pipeline, you push code into the code commit, which is your source, and then on every push, then your tests are going to be running within CodeBuild. You can also build and store Docker images automatically using CodeBuild and ECR. So how will that work? So well, whenever you are building an image, then the script within CodeBuild is going to build a Docker image, and then push it into Amazon ECR using some commands, and then finally you can do automated CloudFormation deployment using CodePipeline by first pushing it, for example, to a code commit, and then using the CodePipeline deploy stage to deploy your CloudFormation templates. Okay, that's it for this lecture, and I hope you liked it, and this was easy, and I will see you in the next one.